What's going on YouTube? Jack Lee here, and we're back for another Java programming tutorial. This time we are going to make the Minesweeper game. If you've never played it, here's a good time to try it out. So Minesweeper, as familiar to many people, is a puzzle where you click on the blocks on the screen and it technically reveals all the squares, the needed information for you to solve the puzzle. Now, these numbers mean that these are numbers of the number of bombs. So these are numbers of bomb around the vicinity of that block. So this one, it shows the number of bombs around this block. This one shows the number around this block, around this area. Only the adjacent areas, right? So this one has a bomb around it, and it only comes in contact with this one, so we know there's a bomb here. And if we click on it, we lose. So it's as simple as that. Now, there are certain things we need to understand here. Let's turn that down a little bit. It's too loud for me. So if you look at the way it works, if you click on a block that is blank or it doesn't have any bomb around, it's gonna open all of the blocks around it. Let's see. If I click on this block, it has a bomb around it. It's just gonna stop there. But if I click on this thing, it's gonna open this thing, and open this thing, and open this thing, and open this thing. And every single time it opens that, it opens all the block around it. Right? So if it opens this one, it's gonna stop opening. But if it opens this one, it's gonna open all the blocks around itself. So what kind of algorithm do you think we should use? The answer is recursion. So what is recursion? If you are not familiar with the concept, I'll use paint to demonstrate. Recursion, say we have a grid here. We have this. Please excuse my drawing skill. Okay. I think I'm just gonna drop another block down here. Now, in Paint itself, there is a function called the Paint bucket, right? So this is a little tool called the Paint bucket, and what it does is when you click on something, it's gonna fill the whole area with that color. So how do you think we should do that? It's gonna be really easy if you do it with recursion. So what is recursion? Recursion is technically the idea of calling itself out. So technically what paint does is that, say these are really huge, like these are just individual pixels, but I just blown them up to a really big case. So say I fill everything around green, or green. So all these pixels are now green, right? All these pixels are green, and these pixels are what we want to fill in. So let's say we want to fill red into here, and all of these being red is the desired result. Okay, so we can use recursion to fill all of these red we are going to call, let's say this is a pixel we click on. We call fill red in this pixel. So what it's gonna do is that it's gonna look at this pixel. We're gonna detect the color of this pixel, right? And we throw it into the function called paint. So the function paint technically the paint what it does is that it's gonna take in the comparison color, the background color on that pixel. It takes in the color that it needs to paint the pixel with, and it just takes that and it goes. So we throw in a red color, and the comparison color or the background color is white. So it goes to this pixel. We click on this pixel. It goes, hey, this pixel is white. Let's fill it with red. let's draw a red pixel on it. And when we do this, we are going to call the paint method, or the paint method on this pixel, this pixel, this pixel, this pixel, this pixel. So let's call it on this pixel. And when it call it on this pixel, it's gonna, because we have the recursion call, it's gonna call the pixel up here. And then when it calls the pixel up here, it's gonna call the pixel up here. So this pixel, all the calls from this pixel is not satisfied yet, but it has to go all the way through the block, right? No, the block, I mean the stack. So it queues everything up until the final condition is met. So that condition is called the base case. So what is our base case? Our base case is that the color is not white. Our base case, if the color is not white, do not paint anything and do not call anything else. Right? So let's do that again. So we call this one red. This one will call the top one red. Also has the call on this one, the calls on this one, calls this. For the sake of this, let's not call the diagonal ones. Just when you paint something, it's gonna call this one, this one, this one, this one. Alright? So let's walk it through here. So when it calls this one, it's gonna call the top one, and this one after it calls this one out, this one will call this one, this one, and this one, this one. So it's gonna call this one, and this one is gonna call the top out before it satisfies anything. But the top is not white, so it hits the base case and it stops. So to this one, it calls this one out. This one is perfectly fine because it's white, right? So it calls this one out, and this one, when this one is called out after it paints red, it's gonna call the top one. But this one hits the base case, it's not gonna do anything. It's gonna call this one out. This one hits the top, base case, but the bottom doesn't hit the base case. So when it calls this one out, it's gonna check if this is white. This one is not white anymore, it's red, so hit the base case, not base case. Call this one out, base case, not base case. And this one calls the top, and only when it's here will it satisfy. No, here it is surrounded, like there is no more anything else for it to call out. So this one is satisfied. So this one will then call this one, but everything around is satisfied, so it goes back to this one. Now this one was already satisfied because this is the last one for this one. So it goes back to this one. This one is also, well, it was right here, so it called this one out, but this one hit the base case, so it goes back to this one, and it goes all the way back here, all the way back here up to this point. Now this one, it was at this location, or this call at the time. Now it stopped, and it goes down here and it says, hey, this is red, so base case for that, call this one out. This one is not red yet, so it's gonna paint it red, checked around. This one is not red. Not red, it's still white. So yep, fit condition, call the top, call the right, call the bottom, print out, and then it has everything. That's technically what the idea of recursion. Calling until the base case, the final condition is met. And every single time it calls, it has to call with a different precondition, different parameter. So, sorry for the lengthy explanation, but that is what we are going to use. That's a really important concept for this game. Is the heart of Minesweeper. So let's go ahead and create a Java application as seen in the other MS will be Minesweeper, right? Okay, now we have the main class, and let's cut all of these out because it looks really cluttered. In reality, it will be better if you have documentation, but not now, right? So now we have the main class. We're going to need another JFrame because that's where our Windows is, right? So we'll call it sweep. It has to be that, right? So sweep, and then we'll have to initialize that sweep. So we call sweep swap equals new sweep. So technically we just created the J-frame. Now this game is best played in now it doesn't show anything yet because I didn't show it out, right? But this game is best played at full screen, right? Because I don't know, because I don't like, well, this, when it started out it was like this, it was kind of tiny like this, but I'll just blow everything to full screen here. So I'll say sweep dot set extend the state. Okay, state. Now I don't think we'll need to import anything to go Java. I think Java act the swing dot jframe dot extend, no, hold on, maximize both. This is going to blow it to full screen, right? And dot show. That's a method. That's a void method to show everything out. So it's gonna blow the thing to full screen. That's what we want it. Now let's design this thing. So according to the one that I made, I have a menu over here and I have a J panel that extend to the whole screen, but there's a little bezel on the side. So there's like a little tiny bezel, but everything is extended to like there's only like one J panel in the middle. So we're going to go ahead and do that. Now it has to snap onto the side and has like this little line over here, and it has to snap to the bottom so that it's gonna, you know, be anchored to the J-frame itself. So when you change the size, it's gonna go with it, right? Now in here, the button for, again, I don't like comments, even though they are important. Commentation does not really appealing to me. So the buttons that we use on the Minesweeper game is the J toggle button. This is my game anyways. So it uses the J. Oh, I suck at this game. Okay, so I use the J toggle buttons to show the numbers and things on the screen. Right, so we're gonna use that. So what we're gonna do, we cannot drag out all of the J toggle button. No, we cannot. It is this toggle. It is the toggle button, this kind of button. And you know, like, let me show you a few. Not this one. No, this is not our J-frame even. So let me show you a little personality it has. So the J toggle button. Yeah, I'll keep that there. So our J toggle button, when you click on it, it's gonna, you know, like pop down, and you click it again, it pops up, pop down. But we're going to have to manipulate it. We won't let it pop up and down. So here's how you manipulate it. When you click onto it, action performed. Now this is just to demonstrate. We are not going to use this toggle button at all, right? That set selected to true, so that because you know when you click on something, you cannot pop it back up again, right? So when you click on it, it's gonna be down and you can't pop it up, right? So that's the idea. That's what we want to use. So let's go ahead and delete this thing. What we want to do is that we are going to now we're not going to change the size of this thing dynamically. We will only use one size for the sake of the tutorial. So I'm just going to go ahead and do the exact same thing as we did last tutorial. is I'm going to create the int final int. So final int width, and again we're not going to use the full word of width because it's going to clash with the keyword. So we're going to have a 9 by 9 map here, or 9 by 9 area, and we're gonna have 10 bombs. So yeah, we're gonna drop the number of bombs here. So no of bombs equals 10. Now I declare all of these on the top of the program so we can go back and change them later. Right now, like I said before, we're not going to drop every single toggle button in, but we are going to create them ourselves and manually drop them into the J panel. So to do that, we are going to have to import javax.swing. In this tutorial, I'm just gonna go ahead and then go through everything quickly so that we save time and you guys won't get bored. Because I figured in the last one I just talked a lot more than what I did. I just talked too much. J toggle button. So now we're going to create an array of J toggle button. Not only one, but an array of them. So you create it. Now we're gonna call them block with an S equals to new J toggle button. Not that. No. We're going to create an array of height first and then width later. Okay, so we're going to have a 9 by 9 array of J toggle buttons, and now the toggle buttons are just buttons, right? They're just representation of our array here. We can't just use them as our array because the memory for the block itself is going to be really complicated. So we use them to represent the block. So we have to have an int. Now I have to use an int blocks. Let's use a different name for it here. I want to put it in here so that when I want to reinstantiate it, I can just copy from here to the end. So new int. Now I have to use int because one block doesn't only have one state. It has more than one state, right? Now, if you look at my program, a block can either be open, unopened, or has a bomb in it. And we can control all of them with one integer. I don't think there's any smaller data type for a or any smaller data type in Java. In Visual Basic or in other, well, in Visual Basic there is something called single, but there's no single here, so we have to use an int. So it either pressed on, has a bomb, or not pressed. So for the one to have a bomb, I will consider. Let's get our agreement straight here. So here, now I'm going to use some documentation. Okay. So -1 is has a bomb. 0 not open. From 1 through 8 number of bombs. So when it's -1, we know it has a bomb in there. When it's 0, we know it's not open. And from 1 to 8, that block technically 128 is the number of bombs around that block. Right, so when I say that block is 3, it means it has 3 bombs around it. Alright, so let's do the easy part first. We're going to initiate all of the J toggle buttons. So we say blocks. No, we're going to use a nested loop. So int I equals 0, I less than height I plus plus, and then we're going to have this over again. Indent it. Have J here with J. So now we're going to instantiate all of these blocks. So we will say blocks I J equals new J toggle button. Now we initialize the button into a actual button. This is just to create an array of pointers to the J button or J toggle buttons. Now we have the buttons. So J toggle button new, and we're going to have to set the location for that thing. So if you remember what we did last time, no, we don't set the location first, we set the size first, right? We set the size for that thing first. So what size does it need to be? The size has to be as big as the J panel width, or oh, sorry. So that set, it doesn't have set width, so we have to do everything in here. So set size. Oh man, set size, and because that size can have individual width and height. So set size, we're going to divide the J panel into the width amount of, I just hate this thing, you can't press tab, divided by width, and height divided by height. Much time ahead. So that will set the width for each individual block. I J dot. Now we're gonna drop the block into the J panel. So we're going to have to say J panel dot add component, no get contain content. Hold on, this is so weird. So we should add, just add, not add component, just add the block in. Alright, so now the block will be added in, and now we set the size, the location for it. Set location XY, and for X we're going to use the J times J panel 1 dot get width divided by width. Technically what we the same concept I used in the last video I had. Just technically divide the whole panel into how many cells in each dimension, and I think that's it. Let's see if it works. Yes and no, yes and no, because we have to have a resize method. So let's go ahead and make a resize method here. So private void resize, and again, no e. Try not to clash with the keyword. So resize, and I'm just gonna go ahead and copy all of these in because technically that's what resizing is, without initializing though. So yep, without the initializing part. But you know what? Yeah, it's gonna be redundant like that. I was thinking of initializing it up here and then call resize. So and then whenever this thing's it's when it's resizes, like when it resizes, we are going to call the resize also. So technically it's gonna you'll see, it's gonna resize the thing, so the size of the small button according to its own size. So far we have created all of these. So now we have to write the code for what? For each individual block, right? Now the way to do that is we have to import the action listener. Java dot awt dot event dot action. Hold on. Event dot action event, and we have to import now action event. Hold on. Yeah, right. So we are going to make an action event here. Action event action, or no, we have to have an action listener. I think that's what I did. So let's see, action performed. So we have to somehow add the action listener in, and the action listener will have the action event E, right? So yeah, we have to add the action listener in also. So I'll import java.awt.event.action-listener. There we go. So action listener is technically the subclass of the action event, and used specifically for this one. So we're gonna go action event. No, not action event. Action listener. Listen equals new action listener, and when we call it out, we have to override the action perform method. So we are going to go public void public void action performed and action event E. Alright, so what does that do? Action performed. Oh, action performed with no, not capital A. Yeah, I made the mistake last time too, and it took me like 15 minutes to fix. So yeah, so this one, so this actually, so technically what it does is that if you see in here, if you say if I create an action, if I create an event here, the Java is gonna go ahead and go into the thing, and it's gonna generate all the code needed for that thing for you. Now, when you manually add everything or anything into the J frame itself, you are going to have to manually write all the action listeners for it. So I'm just gonna go ahead and go through it really quick. I'm sorry, I just hate all these cutting off so much. So what I was saying is I'm just gonna go through the process of adding the action listeners really quickly. If you don't understand it, it's okay, because it gets quite confusing sometimes. So what I'm doing is that I am going to add the action listener. Add action listener to so technically whenever we click on any of these blocks, it's gonna send a action to this guy, and this guy is gonna pick up the action. Now we do not know which one sends the action, right? So all we know is that, well, we do know which one sent it in, but like we don't really know what where in the array it is, because now the array of blocks are a whole bunch of pointers that points to different objects, points to a whole bunch of different, you know, block objects, right? And the blocks object, when it send the action into the action listener, it is sent from the object itself. It sends from the object in that memory location. Or block is just a pointer that points to the array or points to the object, and this object sends the action to the action listener. So it's kind of blind in terms of index here. So what we have to do is that we're going to have to look through the whole bunch of block, a whole bunch of pointers, and to see which one points to the same object, right? So what we have here, let's just erase everything. So we have an object in an array. Let's make it black. We have an object in it. This is the object, and this is our blocks. Let's use a pencil. Oh my god. Yes. So this is a pointer, and this is I cannot write on the pen, on the mouse at all. So this is our blocks object, right? It points to this thing, and this object is what sends the event to the action listener, AL. So this action listener only knows which object sends the event to it, but it doesn't know which one points at it. So which blocks object which blocks pointer point at it. So what we have to do is that we have to look through it. So int I equals 0, and j equals 0. This is my method of finding it, right? I equals 0. We have to type it twice for some reason. Even though in C we can just say I equals 0 outside, and in here we just type the conditions in, but in here it doesn't work for some reason. I++, where to create a nested for loop, and in here we have to make a boolean, found equals false. Just gonna go through this, and then so if e dot get source equals to blocks I j, then found equals true in bracket, and if we found it out here, if found bracket, so technically it's gonna scan through the thing and until it finds which one sends the object in, which blocks sends the object in. It's gonna break the both of them. Not break in here, break out here. So it's gonna break the array, and then we say, well, let's test it out, right? So we'll say blocks dot, I j dot set text. Hello. Yep, technically that, and then when we click on it, for some reason, yeah, I think we have to declare this out here. For some reason. Oh yeah, because it's gonna keep saying false and we'll see if it works now. Apparently it doesn't. Oh, sorry. I just copied it down without changing anything. Well, actually, no. I is height and J is width. So I think it should work now. See? So now we click on it. It's gonna look through the whole bunch of pointers, see which one points at the one that sends the action in, and it just works there. So what do we want to do with it? So the first thing first, we're going to have to press it down and not let it pop back up. So select it, true. So no matter what, when we click on it, it's not gonna pop back out. That's the desired effect. So now we're gonna have to let's do the recursion part of it, right? The recursion is the fun part. So what I want to do is that I wanna say oh, let's spawn the bombs. Why? How about that? Spawn the bombs. So now many people here, say I destroy this and I restart the game. It says when you restart the game, you may lose at first the bombs at the same position. You may lose at first click. So if I click on the exact same spot, I'm gonna lose. But if I click play again, it's gonna spawn the bomb after I click it. So we're gonna simulate that, right? We're gonna try to find a way. So let's say so we're gonna create a spawning method. Private void spawn, and now we have to take in two parameters because actually X and Y. And we have to know which one we click on, and then we send these in, and it will try to avoid that one as much as possible. Right, so now remember we have the no of bomb, so number of bombs are 10. Number of bombs is 10. So we'll spawn 10 bombs. So and k equals 1, k center equals 2, no of bombs k plus plus. So technically it will do this for loop 10 times from 1 to 10. We're not going to use a k at all. So how do we spawn a bomb? Go int I equals to, now we need to spawn it randomly, right? So randomly we're going to use math.random, but math.random is going to be a integer, so we have to cast everything into int. Oh no, math.random will be double. We return a double. Math.random, this is gonna return a number from 0 to 1, but it never, in a really rare case, will hit 1. I've never seen a hit 1 yet. So what I want to do, so if you multiply this with the width, is never ever gonna spawn any bomb over on this side. So what I want to do, there's a neat little trick, is that you add 0.99 into it. So what it does is it's gonna add it's gonna spawn all the bombs, including this side. But if you say like add 1 to it, there will be a really rare event. It will spawn a bomb on the right, on the outer bound of the array, and that is not cool. So what I did is I multiplied by 0.99, so it's never gonna hit that one, but it's gonna include the right hand side of the width. So let's go ahead and do that. Hold on. No, actually minus 0.01 because the last because width is the number of horizontal object, right? Horizontal cells. So if we say width plus 1, it's gonna be so the index of the last one is width minus 1, right? So we can say width minus 1 plus 0.99, which technically will simplify down to minus 0.01. So we're gonna do that for both I and j. Of course, this is height. Try to be consistent even though they're the same number. While. What while? While this one is not the bomb. So technically, because if we just say spawn 10 times, it can iterate through. It can spawn 2 of the bombs on one spot twice. So we need to avoid that. So while that block, I mean, what is the variable you need? We use blocks for that. So at I and j is not -1. So if it's not the bomb, no, if it is the bomb, then keep looking for location. Alright? So keep searching for the location until it's not a bomb and I is not equals to x. And let's see. So we need, so only when I equals to x. So what we can do is that we can say, now this is what gets confusing here. J, oh no, I is not x, I is y. J is x. Okay. But when we say this, what does it mean? It means that while, hold on, oh, equals. But what we mean is that I and j cannot be equals to y and x at the same time. So what we mean is this. What we mean is this. Equals x equals y. So either we leave it like this, because in here, not the case that we have I equals to y and j equals to x at the same time. But if we want to break the thing and we negate the whole thing, we have to use what? De Morgan's law. So this will have to turn into a OR statement. The negation of an AND statement will be a OR statement. Negation of an OR statement will be an AND statement. So P, not P and Q will be equals to not P or not Q. Yep. So if you've taken that, or if you've seen it, that's technically what De Morgan's law is. So if I is not y or j is not x, oh well, just ignore that. We have to use an AND statement. We're not negating anything. So sorry about that. So while it's invalid technically, so keep searching for the statement. Keep searching for the location. So we're gonna have to do that all over again. Actually, we can just use a do while. Why not, right? So what I want to do is int I and j, and then do block. Do this. Yeah, do while will work better. So int I and j out here, and then we do a do while loop. There you go. Oh, we have to go. Okay. Sorry for the cutoff as usual. let's see. So it's gonna throw some error here, because it will throw some error eventually, because we have not initialized these guys yet. And hold on, no, it's not gonna do anything. So I think we're fine there. So what it does is it's gonna use a do while. It's gonna assign some number here, and then it's gonna check if that thing is still invalid, then just keep searching for the location where it is valid. And if it is valid, then I will use blocks I and J at that location to -1. So technically we just spawn the bombs, right? So now when do we know we need to spawn the bomb? We spawn the bomb after the first move, right? So how do we know the first move? We're going to need a boolean. I just call it start, or first. Okay, equals false. So first, at the beginning, first is false, and so technically first is what it means. First means that we have not clicked the first move yet. So at the beginning, first is false, and yeah. So at the beginning, first is false, and when we click on the action perform here, we are going to spawn it. If first though, if not first, then spawn. Right, so we're gonna spawn the bomb where to spawn, at I and J, at the exact location that we're on. Spawn the bomb, then set first to true, or the other way around. It's totally up to you. So so let's see if the spawning method works though. Right, J equals boom. I mean sorry, the set text. Boom. So it's gonna say boom wherever the bomb is. So at the beginning there's no bomb yet. We'll click on something, it's gonna try to dodge this square. So it's gonna try to dodge that block. It's never gonna hit the block at all. So that is a desired result. It's gonna search for anything that is not the block, and let's count the bombs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly 10 bombs that we needed. 10 bombs that are not overlapping each other, and is not on the one that we clicked on, right? So spawning method done, checked. Let's see what else I did. It's good to have something that I've already done. So now to the open method, I think, because this is the longest one, and without it, it's like, this is like the heart of the game right here. Alright. So again, when you click on an empty block, it's gonna open, and technically when you click on something, it's gonna say open that block. Alright. So before we do that though, I want to add another thing in. We call it can play. Another boolean set can play. Why? Why do we need this? Yeah. Let's do that at the constructor. So it's just more intuitive, you know. So let's see. The constructor is over. Where's the constructor? Sweet. There we go. So at the constructor, say first equals false, can play equals true. Why do we need that? Because if you lose, you cannot click on anything anymore. That's what I want to do. So if I lose, can't play is false. So let's see. So action perform. It's only gonna actually no. After it finds the block. If can play, then do this. Or else. Else, we'll take care of that later. So if we can play, then do that, and we're gonna start making the open method. So private void open. Open where? Int x and y. Oh, well actually you have to go. Oh, on the spawn we have to go y and x just to be consistent, because we say spawn I and j here, right? So it has to you know, be consistent. So we always go I before j, right? So we have to int x and then int y. I mean int y before we int x. Yep, int y, and y will always be associated with j. Y will be associated with I, and j will be associated with x. Just to keep that consistency. So what do we do when we open a block? First we're gonna have the base case. So what is our base case? If we open, if the block, okay, click on this thing. If we open a block that is that has a bomb around it, it's gonna open, yes. Okay, let's see. What is a good example of that? If we open a block, okay, if I click over here and it opens this one refuses to open anymore. And it's interesting because, oh yeah, so base case is that it's gonna, if we try to click this one, it's gonna open a block up here, right? But up here there's no block, so it's gonna be a negative number. So we're gonna throw some negative number in, and it's gonna take that. It's gonna still open, but if it takes in any negative number less than 0 or x is less than 0, if any of those is negative, return. Right? I think that should be the base case, because we react to different things differently. So when we click on this thing, it opens this one out. This one will still open, yes, but it's not gonna open anymore. So it's not gonna call anything out anymore, but it's still gonna open, right? So I think we should declare a int bomb here. Technically, how many bombs around it? Initialize it to 0. So here's the tricky part. So how do we find the number of bombs around it? The easy part, the easy way is that you have the location of what we want to open, right? So let's say we want to open this thing. To open that, we are going to check around it to see how many bombs there are around it. But if you click on the bomb, you're gone, right? So if you click on the bomb, you don't have to check for that. So what you want to do is that you're going to find all the bombs in this 3x3 block, right? So I'll go for int I equals int I equals y minus 1, and then I less than or equals to y plus 1, and y I plus plus. So that will check all the 3 blocks around it. Of course, we need one for j also. J will be related to x. Alright. Now Now, the conditions are that if we click on this one, it's gonna scan out here too, and it's still gonna scan, but we're not gonna check if the y and j are negative, right? So if now we have to use De Morgan's law. If it is not the case that j is less than 0, or the case that I is less than 0. So what does that mean? If we throw a number in that is totally out of bound, we're not going to check for it at all. So this is to check if it is a valid number, right? So if j is less than 0, another case is j is less than 0, or the case that I is less than 0, or the case that j is bigger than width minus 1, or I is bigger than height minus 1. So technically it's check for that condition. So if j and I are perfectly legal, and now we do the AND condition, and there's a bomb there, right? So if I and j are legal and there's a bomb there, so blocks, I think blocks is what we save the bombs, right? So blocks I j equals -1, then we're gonna open it. So what do we open it into? The way we open it is that we say block I j equals, no, we don't open it yet. All we do is we check for the number of bombs, right? So we can say bombs plus plus. Alright. Now it's gonna add one bomb in if there is any of the bomb in that vicinity. So now out here we're gonna check if there are more bombs. So bomb is bigger than 0. If there is a bomb around. Oh no. If there is no bomb. First, if there is no bomb, then open around. If there is a bomb around it, it's not gonna open. It's gonna stay. Alright. Now note that I did not open anything here. Right? Bombs is 0. Keep checking. Let's see. We're gonna say blocks at this point equals the number of bomb. Okay. And then and only then, we still have to and I and j out here. Oh, wait, no. Sorry about that. No, we're gonna go y next. Y next will have the number of bombs at that point. So technically, we're gonna change, because it was a 0, it is open. 1, it is not open. Right? So if there is no bomb there, it's gonna call itself out. It's gonna call all the numbers in the vicinity. So technically we can just reuse, we're gonna call all of these out. Instead of checking for the bomb, we're gonna call the bomb out. So yep, that's another cutoff. So what I was saying is that instead of calling the checking the bomb, we're gonna call the bomb, but I need to add something to the base case here, because x and y less than 0, there is still more cases that are illegal, and those are these. So if x is bigger than width and -1, and so technically if it's out of bound on the right hand side and below the technically out of bound, technically these are all out of bound checking. We're not gonna check if the thing has a bomb or not, because I don't think we'll have a chance to ever open the bomb. So we're gonna preemptively prevent that from all the way up here. So if we're gonna say if there is a bomb there, then we're just gonna call the loose method. Technically it's gonna show all the bombs around. Alright, so now we are going to call all of these out. Now before we call them out, we have to check if okay, if I is not x, or because okay, here is De Morgan's law. I remember it. This is where De Morgan's law come in. So what we need is that if it is not the case that I equals x and j equals y, right? No, the other way around, sorry. The other way around, if not the case, these two happen at the same time, then we call open I and j. Okay. Yep, that's about it. That's about it. So the De Morgan's law come in when we want to distribute this in. So I'm just gonna go ahead and do it, just to give you the concept of what De Morgan's law does. So I'm going to distribute it in, and we have to turn this into the other sign. So if it is an AND statement, we'll have to turn it into an OR statement, or else it's not gonna work. Alright, so open some more, and when there is no bomb. What if there's a bomb? Well, if there is a bomb, then it's gonna turn that into a thing, and we are going to, okay, we're not gonna do reval. Okay, let's make a revalidate method. Why? This one is going to check which one is open, which one is not. It's gonna, you know, move the J button, the toggle down and up, and change the text on it to match with the blocks. So technically, it's gonna present the blocks out to the screen. Alright, so the same thing we're gonna do up here. So I'm just gonna copy the. No, not even that. That's the for loop. We're gonna look for the for loop where we, you know, where we iterate every single thing out. Let's go integer I, int j, and if the blocks at the time at the point is equals to, let's say 0, then the blocks, now this is the J toggle button, at the spot will dot set text to nothing, and also the blocks we will set, if there is no bomb there, we're not going to show any text at that point, and set selected into false. So that spot will be popped up. Or else so if blocks at a point is bigger than 0, what we're gonna do, we are going to set the text into the text. Now we have to turn the blocks at the point to text, so I'm just gonna do the cheap way and set selected true. I mean this true, so that anything that is pressed down is gonna pop down. Right, so far, after you call everything out, you're gonna call the reval. The reason I call the reval outside, there is a reason for that. Okay, so I guess we can just open the block now. Open at the point ij, and then revalidate. Hopefully it's gonna work. So far, oh yeah, see, base case. Huh, that's funny. Okay, let's you know what? Let's not do this. If it's 0, do nothing. Cause what I wanna do. See, there is a problem. Like when we click on an empty block, it's supposed to open everything out, right? In this case, it does not open. Why is that? Okay. So apparently, yes, we forgot to check for the validity of the I and J. So I'm just gonna go ahead and do it really quick. That. Hold on. It's not the case that I is less than 0. J is less than 0. So it has to be valid before it does that. So click on anything that has a number. It's not gonna open anything. Click on the empty block though. Supposed to open everything out. Oh, okay. Yep. Hold on. Okay. If it is 0. Oh, wow. Like we said before, 0 is not open. So open has to be something, right? Open has to be something. So if bomb is 0, we will say blocks equals -2. So let's add it to our agreement here. -2. I know there was a arrow down there. Opened. But no bomb. Okay, yes, it threw an error because I forgot to put the indices. I mean, I and J. Yeah, not I and J. Y and X. Okay. So it opens the thing out, and it pops a bomb there. And if there are more bombs out, so else, just gonna go ahead and give it the number of bombs at the spot. So bombs. And again, it's not gonna have a chance to open the negative. Huh. Okay, I understand that now. Let's see. Let's go back to there. to the revalidate and not 0 but -2. If it is 0, then we're not gonna care. Right, so poop, poop. It's supposed to open everything around it. That's funny. So if there is no bomb, then open everything. If there is a bomb, then opens, but doesn't do anything. That's interesting. Did I throw any more exception? Stack overflow error. So it kinda called that. Kinda overflowed it. Okay. So we're gonna have to add something else into our if statement. Or the base case. Or the base case. Yeah, let's add it to the base case. Or the block at a time. Yes, because we did not have the base case that is not 0 technically. Yeah, if it's not 0, then don't open it. I think it should work now. Nope, still doesn't work. There has to be a bomb here. I think it has something to do with our revalidation down here. So, oh my god. True. Okay, I think it should work now. See? That's amazing. Yep, so far, this is a bomb. There's a bomb here. No, there's no bomb there. If there's a bomb, it's still gonna open, but yeah, we kinda know. But so far, it is working pretty fine. So, well, let's take a moment and admire what we have done. So, okay. Wait, what? Why did it not open anything when I clicked there? It's supposed to work, right? It's supposed to... Oh, there was a bomb there. Sorry. Okay, so let's go ahead and make a bomb. Now, on my thing, I kind of added a picture, a little icon of the bomb in. You can do that if you want, but for this tutorial, because it's been a while, it's been almost an hour and a half, just gonna say boom on every single one of them. How about that? Yeah, let's just say boom and you lose. You know, simple things. So like I said again, before we open it, we're gonna go into say if blocks at the point I j is not -1. So there's no bomb there, then we're gonna open it and revalidate. If there is though, else lose. So we're gonna write a loose method, right? Private void lose. Technically, what it is that it's gonna not let you play at all. So can play first. Can play Yep, guys, this should be the last cutoff because we are so close to finishing with this. So let's just go ahead and finish it. Can't play equals false, so we can't play anymore. And what we can't play, what we're gonna do is that we are so we're losing, right? So what I want to do is I'm gonna check the whole screen and just press anything that needs pressing. So okay, that. Okay, I and J, and then if blocks at that point. Now we're gonna reveal all where the bombs are, and to do that, go I J equals -1. Then blocks at IJ dot set text. Like I said, I'm just gonna say boom. And blocked at a point will be, click down. So select it. Select it. False. I mean true. So when we happen to click on a bomb, it's gonna show where the bombs are. But do you know why it does this? That is because we said we can't play anymore, right? So else we have to reval. So that will take care of the bomb being clicked and unclicked. But if I want to do that, we'll have to go if this. So this will take care of the unclicked bombs. Right? So false. So I think that's it. That's the game. See? Now we just keep revaling and we can't do anything about it. I wanna go ahead and okay. So we're gonna go ahead and check for because it's a little problem, see, like if we can't play anymore, see, now it just works, right? Now it opens everything out. It's just like a regular Minesweeper. And see, but the thing is, if you click on this thing, you click on these, you can't change them. But if you click on this one, see, it pops the bomb up because we did not do anything by the bomb when we revalidate. So if not can play, so we cannot play, then we're gonna start checking for the bomb. -1, and we're gonna press it down. One line, and we fix the problem. Wow, I just die on the first move. That is not cool, man. So there is a reason we died on the first move. There's a reason. So that means it did not work. It did not spawn the bomb randomly. Let's go back and check for it. Oh, blocks or statement right here. It's not gonna happen again. It's not going to happen again. Okay, so we can't die because the reason is that I have to or this block because either if there's a bomb there or that is where we click on, not both of them at the same time. Yep. So I just died. So yeah, I'm just not too good at that game. So let's see what else we need. We need to check if we win, right? So private void check win. Check for if we win is super easy. You just check if there is any unopened locked, right? So same thing we're gonna do here. No, not that one. I'm just trying to reuse my code so that I don't have to, you know, retype everything every single time. So first, it should not be a void either. Or should it? Yeah, it can be a void. And we're gonna say boolean 1. So we're gonna need a boolean 1 here, and then go false. No, true. And then if there's a blocks at that point that says, hey, you didn't win yet. There's a unopened block. So unopened blocks is 0. Then keep going. Right. So so 1 equals false. So there's a block. There happens to be a block that at that point. Let's break it there too. Or not. Yeah, let's break it here. So that it doesn't have to like go through the whole thing, even though it knows that it's not winning. So if not 1, so if 1 is false, then let's just go ahead and break both the loops. And then we'll say if 1. So if the 1 boolean survives the whole thing, we're gonna throw something out to the screen. We're gonna say java dot awt dot j option panel. No, then not AUT. Then java x dot swing dot j option pane dot show show dialog. Just mess it out. Dialog. The observer or whatever this thing is should be null. And just say you won or you win. That's it. That's about it. Oh, and if you win, then I think you can't play anymore, right? So it can't play equals false. So if you win, you cannot play anymore, and you have to click new game. But you lost. I lost. So wow, this is my lucky day. I can now open anything. Yep, there we go. Let's see if we can win here. Okay. So bomb here. So there are 2 bombs over there. So this one's safe. This 3 are safe. This 2 bomb. 1 bomb. 1 bomb. 1 bomb. 2 bombs up here. So there's 1 over there. So there are 2 bombs here. So these are safe. These are safe also. This one is already a bomb there, so should be safe. 1 bomb here, 1 bomb here. This one's safe. No, I did not win. Let's see. There's a bomb here. There's a bomb here. There's a bomb here. We have 10 bombs, right? 1, 2, 3, 4, 5, 7, 8, 9, 10. So, oh, we did not call it. Silly me. what do we call it? Excuse me. Check win. Okay, let's do that again. Two bombs here, some pot. Okay. I have to close it to reset. We're gonna make a reset button soon. Hit 3 bombs, alright. Good. Let's see, there's a bomb around here. Now there's a bomb there, so there's a bomb here, bomb here, bomb here. So 2 bombs there, save here. And I win. Yep. That's it. That's a game. Of course, if you want to do the flag, you can just toggle it. It's not gonna be that big of a deal. If you want to do the flag, you can do it. You can totally do it, but I'm not gonna do it now. I will. I may if I still have time. So I'm gonna drop a menu bar in. You're not gonna need that. I'm gonna name this one game. Then name it game. And there's another menu item. Drop into the menu bar. So this one new game. Double click this shortcut to set the shortcut, so Control N. We have a new game. Okay. So what are we gonna do at new game? What we want to do is that we are going to revalidate it. Not revalidate. We're gonna set everything to 0. So we're just gonna go ahead and reinstantiate the blocks and revalidate it. And then the garbage collector, of course, is gonna collect the rest. Reval. That's it. So yep. Boom. Oh yeah, we forgot to turn the can play back on. So can play goes true again. So yep. Boom. Yeah. Either click that or we can click. Oh wow. Oh, forgot. Because it didn't spawn, so we have to go first goes false. It should work now. See, die, Control N. You see, there's something. You see how slow it does? See, there's a. Let's increase the size. Let's make it 30 by 30. Okay. Watch this. Do you feel that? Do you feel it? It has something. So, what is that? That is a really... Oh my god. Facebook, please. So that has something to do with the the repaint method. Now, when we do the revalidation, we only check for each individual one of them, and we just press that thing down. So what it does is that it's gonna press this one down, and that one is gonna in turn call the repaint method for its own self, and then because we press everything down, right? But we already pressed everything down, but thing is, it repaints that button. It has to repaint everything else, but it's gonna repaint that button, and then the other one wants to repaint too, but can't repaint at the same time, so that they have to queue up. So they queue up and they call out one by one, which is extremely inefficient in this case. So what you want to do is that after the revalidation, you tell, hey JPanel, you have to repaint it. So just an extra thing that you what do you know I'm a horrible promise keeper. So I was at repainting this thing, and I think that should be it for us. So after you repaint it, the it's not gonna happen again. The delay is not gonna happen again. So this is without the repaint. And this is with the repaint. So since I just came back from a cutoff, I want to explain a little bit more on the repainting thing. So I was kind of at explaining why it has to, you know, repaint the thing. Now the thing is, when you repaint the J panel, it repaints everything on the J panel. It repaints from this corner all the way down to this corner in one run. But if we repaint every single thing like individually, if we paint everything individually, it's gonna paint this thing in one loop, and then paint this thing in one loop, paint this thing in one loop, and it happens sporadically too. You see, it doesn't paint everything in the array like that, because the repaint method is like the garbage collector. It just happens when it wants to, and has a set of delay. Right, so that's just some extra thing in Java that you kind of need to know, or Swing in particular, that you need to know about. I guess that's it for us. Thank you for watching. I need a comment and subscribe, like the video if you like the video, and I'll post the link in the description for the download, and just ask me if you want the actual source code of my game that I did. Now the reason I did not the reason I don't post this online, or post this to you, because that I don't wanna, I just don't wanna you know, like give you the mismatch between the thing we do here and the thing that I did. But I'm totally willing to share whatever I did with you. So I guess thank you for watching, and I'll see you guys next time.